This video goes over how to solve equations with fractions. So the first thing that we want to do is clear all the fractions by multiplying all the terms by a common denominator. The second thing that we're going to do is distribute any terms into their brackets. So we're getting rid of the brackets. Then we're going to collect variable terms on one side of the equation and number terms on the other side, which we've done before in our previous practice with solving equations. Then we're going to simplify, divide both sides by the numerical coefficient, and then you can check your answer. We'll do an example of a formal check on one of the examples, but you can also do a quick check by just subbing in on both sides. So let's look at the first example here. I've got a simple one-step equation. I see that my fraction is over 5, so my common denominator is 5. I'm going to multiply both terms by 5, which cancels out my fraction and gives me x equals 20. In my second example, I see that my two denominators are 5 and 3. I know that between those two, my common denominator is 15. So I'm going to multiply each term, so everything that's separated by an addition or subtraction sign, I'm going to multiply each of those by 15. As long as I've multiplied by the correct common denominator, I should be able to cancel out my fractions. So 15 divided by 5 leaves me with 3. 15 times 2 is just a number, so I'm not too worried about that. And then 15 divided by 3 leaves me with 5. So that means I'm going to end up with 3x minus 30 equals 5x. Now I'm looking at an equation that doesn't have any fractions, but it does have variables on both sides. What I need to do here is I'm going to take my variable term that's on the right-hand side, and I'm going to move it over to the left-hand side by changing the sign. So now my left-hand side is 3x minus 5x. In the same step, I also want to get my number onto the right side. So I'm going to move that over by changing the sign. So my new expression is 3x minus 5x equals 30. You can also think of it as to move the 5x over, I'm going to subtract it from both sides. And to move the minus 30 over, I'm going to add it to both sides to get a 0 pair. That's the exact same step. Now I've got two x terms, so those are like terms. I can combine those to get minus 2x. And then my final step is to divide both sides by minus 2, leaving me with a final answer of x equals 50. Let's try a slightly more complicated example with some more fractions. Here I've got three fractions that I'm trying to clear, 3, 2, and 6. Looking at those three numbers, I know that my common denominator is going to be 6. So I'm going to multiply each term, everything that's separated by an addition or subtraction sign, by 6. Now, as long as I've done this correctly, just like in the last one, I should be able to divide the numbers to leave me with not a fraction. So 6 divided by 3 is 2. 6 divided by 2 leaves me with 3. 6 divided by 6 leaves me with 1. And 6 and x, there's no fraction there, I just multiply those together. So multiplying that through is going to leave me with 2x minus 3 times 3x, because that's what I had as the numerator of my fraction. Then I just have 1 minus 6x. So the next thing I need to do is to expand these brackets. So 2x minus 9x equals 1 minus 6x. Now I want to move all my x terms over to one side. So I'm going to take my minus 6. I'm going to move it over the equal sign by changing the sign. So now I get 2x minus 9x plus 6x. It changes signs when you move it over the equal sign. Now I can collect all these like terms that are on my left-hand side. So 2x take away 9x is minus 7x, plus 6x is minus 1x equals 1. And then I'm going to divide both sides by minus 1, which gives me my final answer of x equals minus 1. Our last example that we're going to look at in this video is one where you've got a fraction on both sides, and we're going to do a formal check, just like we did in our previous examples of solving equations. So let's start by clearing the fractions. I see that my denominators are 3 and 9. So between those two, I can multiply both sides by 18. If you don't find 18 as the common denominator and you use 27 instead, that's fine. Your answers are just going to be a little bit bigger to start with, and they'll reduce to a little bit different result, but you'll get the same final answer for x. So here I can divide them out. 18 divided by 3 is 6, and 18 divided by 9 is 2. So when I multiply those through, I've got 6 times whatever is on the denominator. In this case, it's a binomial, x minus 6. And then in my right-hand side, I've got 2 times x minus 8, because that's what's left over from the numerator. When I multiply those out, I'm going to get 6x minus 36. Remembering whatever is outside the brackets gets multiplied by whatever is inside the brackets. On my right-hand side, I've got 2 times x, and then 2 times 8, which is going to give me 16. And now I can go about moving my terms to get my variable terms on one side and my numerical terms on the other side. Remember, when I bring that 2x over, it was positive on the right-hand side, so it's going to be negative on the left-hand side. And same thing for my number term. The 36 is negative on the left-hand side, so it becomes positive on the right-hand side. When I collect these terms together, I've got 6x minus 2x gives me 4x, and 16 and 36, let's see, 6 and 6 is 12, so I get 52 here. And then I'm going to divide both sides by the number in front of the x, and I should get 13 as my answer for x. Now this one was a little bit trickier. The numbers were a little bit larger, so I'm going to do a formal check to make sure that I have the right answer. So left side and right side. My left side is x minus 6 over 3, and my right-hand side is x plus 8 over 9. So I think my answer is 13. So I'm going to take my answer that I got, and I'm going to put it into wherever I see an x. So I've got 13 minus 6 over 3. And then on the right-hand side, I've got 13 plus 8 over 9. Now, if my answer is correct, my left side number that I get should equal my right side number. So 13 minus 6 is 7 over 3, which is a fraction, that's fine. 13 plus 8 is 21 over 9, which initially doesn't look like it's the same, but I can divide the top and the bottom by 3 to leave me with 7 over 3, which is the same number, which means that my answer is correct. X equals 13. And those are some examples of solving equations with fractions.